Hey guys, for calculus, I like to combine 3.1 and 3.3 together. I'll explain the difference as we start. And for pre-cal, this comes from 4.2, okay? And these are called extremas. So anything that's extreme is always like the most or the least, okay? So that's literally what we're going to be finding today. This is when we start to see in this chapter the application of derivatives, okay? And an extrema is a maximum or minimum on a graph. The other thing we're going to be seeing today, which if you're in cal comes more probably from the 3.3, is increasing and decreasing. So I'm going to give you guys a set of steps, and we're going to be able to analyze through the derivative when a function changes from increasing, has a maximum, to decreasing, has a minimum, and then changes back to increasing, okay? So here are your 6 steps, okay? Step 1 is going to be to solve the derivative, okay? If you set the derivative equal to 0, meaning the slope equal to 0, okay, you will be solving for the x's. Those x values are called your critical numbers, okay? Take critical numbers as like a number bank. It's going to be, critical numbers are your possible extremas, so your possible maximums. So once you get those numbers, you're going to have to start testing for them, okay? And then here's how we do that. We're going to place those critical numbers on a number line. We're going to test the in-betweens of the critical numbers by plugging x values into the derivative, okay? If the x value that we plug into the derivative comes out positive, a positive derivative means a positive slope, which means that the actual function was increasing. If we plug in an x value into the first derivative and it comes out negative, a negative derivative, a negative slope, means that the function must have been decreasing, okay? So that's how we're going to first find increasing or decreasing. Now, the way we determine our extremas is if I switch. So if I'm testing the in-betweens of these critical numbers, let's say this was a critical number, and I found that before that critical number I had a positive slope, so positive slope, which means I was increasing. And then after that critical number, I had a negative slope, which means I was decreasing. That is proof to say that I have a maximum, okay? If I reverse those two, if I test before this critical number and I prove that my first derivative was negative, meaning I was decreasing, and then after that number, my first derivative was positive, which means I was increasing, I have enough proof to determine that I have a minimum. Okay, so increase to decrease is a max, which means you would have gone from positive to negative on the first derivative. And then decreasing to increasing is a min, which means I would have gone from negative to positive on that first derivative. If you test the in-betweens and you do not see a switch in increase and decrease, like if it stayed increasing, increasing, or decreasing, decreasing, then you have neither a min or a max at that point, okay? So once you've found the x values of those maximums and minimums, the way to find the y value, the actual location of where that maximum occurred on the function, is you plug it in, that critical number, into the original function f of x that was given at the very beginning of the problem, okay? Now, I know that's a lot of information. Take a moment, pause the video, write it down. I'm going to explain to you how it works if they give you boundaries. This is going to start to make a lot more sense once you see a full example worked out, okay? So don't stress it. 3 different intervals they could give you, and I'm going to give you a little image also so you can see what that looks like, okay? If they don't give you an interval, you can assume that you're looking at the graph, like these arrows, from negative infinity to positive infinity. So you're going to analyze a number line that goes on forever, okay? So in that case, whatever critical number you find could be your extrema, your max or min, okay? And then you don't have to worry about endpoints if they don't give you an interval. If they give you an open interval, which is, the notation is with parentheses, it means they do want you to stop at a certain location, so you don't have to test past those numbers, but since the parentheses and open interval means that you do not include the endpoints, those are open circles and those do not count as extremas. The third scenario, if they give you a closed interval, so they say test from 0 to 5 included, now 0 and 5 are actual solid endpoints, and those can count as a max or min. So this was a highest point, this is a lowest point, and this is another high point, okay? Now, some vocabulary you might see different. It's rarely asked. You'll hear the words relative maximums, which just mean relative means list any and all high points. If they were to say find the absolute or the global max, then you would just be finding the highest max, okay? For example, on this question, if they'd asked for the relative or the absolute min, being that there's only one, this fits both criteria, okay? So now, some really smart guy decided to put a theorem to this, a fancy name to it, and basically that theorem, which I'm going to show you now, just states that anytime I have a continuous function with the endpoints included, I will have both a max or a min. So for example, let's say the function just went from here to here, even if it was just a straight line. So we avoid this part, okay? If the two endpoints are included and this is continuous, then I will always have at least one max and one min, okay? So let's look at that statement over here. This is one of those theorems that I have you memorize, especially if you are in Cal or AP Cal. It comes up a lot as a proof in the AP test, and it's literally as simple as saying, well, how can you justify that there's an extrema? And you can literally just restate the extreme value theorem. For short, we call it EVT. And it says if a function f is continuous on a closed interval from a to b, then f has both a min and a max. All right, let's check out this first example. I know I gave you a lot of info, but as we work our way through this, you're going to start to see how it all plays out. All right, this question reads, find the extremas and intervals of increase and decrease of f of x on the interval of from -1 to 2 included, okay? So step 1 is to find the derivative. So f prime of x here would equal 12x cubed minus 12x squared. And as always, the calculus was the easy part. Now we have to set this equal to 0. I see that they both have a 12 in common and they both have x's in common. So I could take out a 12 and up to 2 x's. So I'm going to say 12x squared times x minus 1 equals 0. I can set both equal to 0. So here I divide by 12. 0 divided by 12 is still 0. And then I square root of 0 is still 0. Here I add the 1 over. These right here are going to be my critical numbers. Okay? So I did step 1, which was to find the derivative. Step 2 was to set it equal to 0 and solve for the x values. I found my critical numbers. Next, I'm going to put those critical numbers on a number line. There's my number line. I have to always make sure that I go back and check my interval. On this question, I had an interval from -1 included, meaning -1, because it's included, will be either max or min. And then same for +2. Now, my critical numbers, if they were to fall outside of this interval, I could ignore them because they only want me to check in between these numbers. But in this case, 0 and 1 do fall in between. I would just suggest that you space this out evenly so that your work fits. Don't get too crazy. All right, my next step is to test numbers in between. So a number in between here, and in between here, and plug them into the derivative, okay? So if I can find out what the derivative is here, the slope, whether it's positive or negative, if I find a positive slope, I know I was increasing. If I find a negative slope, I know I was decreasing. So f prime of an easy number in between -1 and 0 would be -0.5. An easy number in between 0 and 1 to plug into the derivative would be 0.5. And then an easy number in between 1 and 2 to plug in the derivative would be 1.5. Now you have some options here, and I'm going to suggest options depending on whether you're in pre-cal, cal, or in AP cal. When I plug in these numbers, I really don't care about the numerical value of the slope. I really just care about whether the slope is positive or negative. So laziest version would be to plug this value into my derivative and then find out if it's positive or negative, right? Like with my calculator. Okay, what I would love for all of you to end up to be able to do, and I want my AP students doing this because it is a much needed time saver, is to just analyze the signs. So here was the first time that you found the derivative, and here was you cleaning and rewriting the derivative. At this point, it is beneficial to plug it into this one, and let me show you why. A negative 0.5 squared. Anytime I square a negative, it becomes a positive, okay? So putting that negative 0.5 in here becomes positive, times a positive 12 is positive. So this first term is positive. In fact, no matter what number I put here, positive or negative, this will be positive times 12 is positive. So you're going to see that's going to be true for the rest of this, okay, for this first term. Now look, times negative 0.5 minus 1, okay, I'm plugging this in here, will give me a negative. So a positive times a positive times a negative is a negative, which means that at negative 0.5, which is in between here, I am decreasing. So if it came out negative here, I'm decreasing. Okay? Let's do the next one. We said 0.5 squared would be positive times a positive 12, also positive. 0.5 minus 1 is going to give me a negative. Okay? So, same scenario, positive times negative is negative. I found that I was negative here, which means I was still decreasing. Okay? Last one, 1.5 squared is positive times a positive 12 is still positive. 1.5 minus 1 is a positive 0.5. So here I have positive times positive, which is positive, which means I was increasing. Okay? So now, what that tells me is I started at negative 1, I'm going down, I continue going down, and then I turn back up around. So anytime we said we have a switch from down to up, that means this here is a min. If my endpoints are included, then these are also going to be extremas, either a max or a min. So if I start somewhere and then I shoot downward, you need to ask yourself, was this a max or min? Think about if you're in a ride. You must have been somewhere up high if you had to go downward, which makes this a max. And then because this does not switch, this is neither. And then here, if I went up, 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 and then I stopped, this must be a max. Now, if this interval had parentheses, it means we would not include the endpoints, and I would not have written these two, okay? All right, so for my first set of answers, I'm going to say my intervals of increase. So I was increasing. Now, increasing and decreasing is always used with parentheses because I can't count the actual max as me having been increased or decreasing, okay? So I was decreasing. From 1 to 2 was the only time I was increasing, okay? And I can say that it was because, I know I was increasing there because f prime of x was positive. We can write positive or we can write greater than 0. Now I was decreasing from negative 1 to 0, and I want you to take the same exact pauses that they do. If they pause at 0, pause at 0. We'll figure out why that happens after. I also was decreasing from 0 over to 1. And we saw that that happened. We found that I was decreasing because my derivative was negative, or you can put that my derivative was less than 0. Okay? So that's the first part of your answer. You found your intervals. Let's finish off and find our extremas. Okay? So, all right, here, extremas. The first one we found is a max. We know that we have a max at x equals -1. If I want to find the ordered pair, I have to plug that -1 into my function. Okay? I also have a max over at 2. So now to find the location of where these maximums are, I have to plug them into the original. So I'm going to say f of -1 and f of 2. Okay? So I'm going to plug this -1 all the way back into the original that was given. And if you plug that in, okay, -1 to the 4th becomes positive, and to the 3rd stays negative. So negative and negative make a positive. I have 3 plus 4, which is 7. Okay? So my first maximum is at -1 comma 7. And then I plug in a 2, 2 to the 4th, 2 to the 3rd, and then subtract, and you should get 16. Okay? So these are my two maximums. Okay? This one is going to be a relative max, and this one's going to be an absolute max. Okay? Now the reason is if you were to put these two on a graph, 16 would be much higher than 7. So I know this one, although they're both maxes, this one is higher. Okay? Now, why do I know these are maxes? Well, one of them is because it's an endpoint, and actually, they were both because of endpoints, but because I changed to decreasing and then to increasing here. Okay? Let's go ahead and look at the mins. My min here is at x equals 1. So to find the location, I'm going to plug it back into the function. If I plug in a 1 here, I end up with 3 minus 4, which gives me -1. So 1 comma -1. And because it is my only min, it is my absolute min. It's the lowest this will ever go. Okay? And lastly, just to mention it, because in the AP test, they like asking this, they will say, was the extrema a max, min, or neither? You can say that 0, at x equals 0, it was neither. And you don't have to worry about finding the location there, okay? So, if we're marking our answers, this is one thing they could ask you on the AP test. And then here are extremas. So just to walk you through it one more time, we found the derivative, we set it equal to 0, and solved for our critical numbers by solving for x. We put those critical numbers along with our endpoints on a number line. We tested values in between them. If those derivatives came out negative, it meant we were decreasing. If they were positive, it meant we were increasing. We determined maximum, neithers, and minimums by the switch in increase and decrease. We listed those and even explained why. And then we listed max and mins and found their actual location by plugging it into the original. Let's check out another one. All right, for this next example, it says find the extremas and intervals of increase and decrease of f of x equals x cubed minus 3 over 2 x squared. So here they do not give us an interval. Okay, that's the big difference between last question and this one. So let's start off with our process again. First, we are doing the derivative. So my first term, x cubed, I end up with 3x squared. Minus, when I multiply the 2 to the front, that 2 reduces and cancels with the 2 in the denominator, x to the first. So I really have 3x squared minus 3x. I set my derivative equal to 0. I have a 3 in common and an x in common. So I can say 3x times x minus 1 equals 0. Okay? Since they're separated by multiplication, I can set each equal to 0. And would you look at that? I ended up with the same exact critical numbers. Okay? So now I'm going to put those critical numbers on a number line. Now, I don't have an interval, so this literally goes to negative infinity and positive infinity, okay? I don't have to worry about putting brackets or parentheses. So I do have 3 in-betweens to test. I have over here, and over here. Last time we were forced to pick decimals. Don't pick a decimal unless you're forced to. So an easy number before 0 to pick would be -1. And I'm plugging in these numbers in between into the derivative. So I'm going to say f prime of -1. An easy number in between 0 and 1. Here I'm forced to pick a decimal. And an easy number after 1, let's pick 2. If you guys would have picked -2 or here picked 3, it still will work out the same. Okay, you'll be working with different numbers, but you will still get the same answer with respect to increase or decrease, okay? So remember, here's my derivative that I found, but here it is cleaned up. It is easier to plug into this one, but again, you can get the right answer either way. So let's look at the first. 3 times x. If I plug in a -1, 3 times -1 gives me a -3, which is negative. And now if I put a -1 in here, -1 minus 1 is -2. That's another negative. Negative times negative is positive. So -1, which exists here, the derivative is positive, which if my derivative, my slope is positive, it meant I was increasing. Okay? 0.5. 0.5 times 3 is going to be positive. 0.5 minus 1 is going to give me a negative. Positive times negative is negative. If my derivative, my slope was negative, it means I was decreasing. Okay? And last one, 2. 2 times 3 is going to give me positive. 2 minus 1 is also going to give me positive. Positive times positive is positive, which means a positive derivative, a positive slope, means I was increasing on the original. Okay? So I don't have endpoints. My endpoints are infinities. Infinities can never be max and mins. Infinity is a concept that it goes on forever, not a location of where it reaches some max or min, okay? So I'm going up, 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 up. I'm increasing, and then I change to decreasing. So here I have a max. And then I decrease, and I switch to increase, and that makes a min. Okay? So let's start writing our answers. Okay? I am increasing. This arrow means negative infinity up until 0 union, and here I decrease, so I'm going to skip that one. I also increase from 1 on to positive infinity. And I know that I was increasing because I found that the derivatives in those intervals, so f prime in those intervals, were positive, or we could say greater than 0. Decreasing. I was only decreasing in between 0 and 1. And I know this because when I plugged those numbers into the derivative came out negative or less than 0. All right? Now, I only have a max and one max and one min, so this is going to be easy. I have a max at x equals 0. The way I find the location of that max is I say f of 0. So I'm plugging this 0 back into the original, okay? If I plug 0 in here, 0 in here, 0 minus 0 is 0. So my max is at 0, 0, and we can call this an absolute max because it's the only one. If I had multiple maxes and one was greater than the other, I'd call the rest relative maxes, okay? Next is my min. I know I have a min at x equals 1. I find the location by plugging it into the original. If I plug a 1 into here, I end up with 1 minus 3 over 2, which gives me a negative 1 over 2. So I have 1 comma negative half. And that is my absolute min. Let's box off our answers. They asked me to find extremas. Here's one of them. Here's my min. Here's the other. Here's my max. I didn't have any neithers. And none of my endpoints, I didn't have endpoints, so I didn't have any extremas on endpoints. And then they asked me to find intervals of increase and decrease. And we took the extra step of explaining why. And I do that, guys, because that is one of the most popular questions on the AP, is to explain the why you found those increase and decrease. Okay? If you wanted to prove a max or a min, you would say that there was a max at x equals 0 because I know that there was a max because you always have to use the f prime. F prime of x changes from my f prime changed from positive to negative. Okay, so I found there was a max, increase to decrease, because my derivatives changed from positive to negative. And then the explanation for the min would be the exact opposite. There was a min at x equals 1 because f prime changes from, so f prime on the min changed from negative to positive. And this, guys, again, very, very popular question on the AP test, specifically in the FRQ. So I'm going to box this off as well. They usually ask you to justify your extremas. This is what an FRQ in math looks like. It's beautiful. It's literally these tiny little sentences, no paragraphs needed. And you're done. One more question. All right, so for our last question, same instructions, find the extremas and intervals of increase and decrease for f of x. I threw a trig function in there so we can recap on when we set that equal to 0. And the third scenario, I'm showing you an interval with parentheses, which indicate an open interval. So although we're going to stop at 0 to 2 pi, we are not going to include those as endpoints or extremas, okay? So first step, derivative. The derivative of half x is just half, minus derivative of sine of x is cosine of x. All right, so now we're going to set that equal to 0. Solving a function, solving for x when you have trig functions, in case you forget, it is from pre-cal lesson, I believe it's 4.7, okay? Make sure you go over that. This does come up in the AP test. So in order to isolate the x, I first have to isolate this trig function. So I'm going to move the 1/2 over. Divide by the half. Divide by the negative. And now, once I have the trig function by itself, I am doing an inverse trig function. So I'm asking myself, when does cosine equal 1/2? Now, this is where you're going to be thinking of your unit circle. So cosine is equal to 1/2 on the over 3's, and cosine is positive in quadrant 1 and in quadrant 4. So cosine is equal to 1/2 at pi over 3, that's quadrant 1, and at 5 pi over 3, that is in quadrant 4. Okay, so these are my critical numbers. Okay, now I'm going to put them on my number line. Now I am going to block off 0 to 2 pi. But remember, they are not going to count as extremas because they are not included, okay? And then I'm going to put my pi over 3 and my 5 pi over 3, okay? So when I test my in-betweens and I have trig functions, the easiest way to do this, instead of literally trying to solve for each number, is to analyze what quadrant you are working in, okay? So for example, if I want to pick something in between 0 and pi over 3, I can pick pi over 4 or pi over 6, okay? So I'm going to say f prime, and if you have your unit circle out, guys, and you're just staring at it, it is so much easier to grasp all this, okay? So pause the video if you need to. Open up a quick Google search of your unit circle, and you'll see that in between 0 and pi over 3, you have pi over 4 and pi over 6. Okay? I'm a fan of pi over 4. That's what I'm going to pick. Now, in between pi over 3 and 5 pi over 3, I basically have all of quadrants 2 and 3, and then some, okay? So you could pick an easy point, like pi, because pi has those easy numbers. But again, when you see me plug it in, you're going to see how I work just really with the concept of what the signs are in those quadrants. And then lastly, in between 5 pi over 3 and 2 pi, I have my other over 4. The over 4 in quadrant 4 is 7 pi over 4. Okay? So if I'm plugging this into my derivative, let's look at my derivative when it was set equal to 0. Okay, I can't plug it into these. I'm going to have a positive number minus cosine of pi over 4. Okay, so I have half minus cosine of pi over 4 is radical 2 over 2. Okay, now radical 2 is a value bigger than 1. So if I have a smaller number minus a bigger number, this is going to be negative, which negative indicates decreasing. All right. The trig ones are obviously a little more difficult. Please make sure to have your unit circle out. By the way, AP, you will be expected to do this without your unit circle. So if you feel like you need to practice, have it out, rememorize that. But you will have to get used to doing it without the unit circle next to you, okay? So for the next one, I have half minus cosine of pi is a negative 1. Got that from my unit circle. Two negatives make a positive, so I'm adding that, which gives me a positive, which means I'm increasing. Okay? And now last one, I have half minus cosine of 7 pi over 4 is a positive radical 2 over 2. Which is the same scenario as my first portion. So I'll end up with the same answer. Okay? It comes out negative, which indicates that I am decreasing. All right, so just by that visual, I can already see that I switch here from decreasing to increasing. So I have a min. Think about if you're on a roller coaster. If you went down then up, you have a valley, okay? And then I go up and then down. So I switch from increasing to decreasing. I have a max. And again, when it is an open interval, I do not include the endpoints, so those do not count as max and mins. Let's start writing our answers. I am increasing. The only time I increased here was in the middle. So we would say from pi over 3 to 5 pi over 3. And we would say because, okay, we found that because the derivative, f prime, was positive, or we can say greater than 0. Now I was decreasing twice. Here I don't say from negative infinity, I do say from 0. The parentheses indicate that I didn't end up touching 0, but at least I know I was blocked off by that. So from 0 to pi over 3, union, which means and, also from 5 pi over 3 to 2 pi. And I would say because I found that the derivative, f prime, was negative, or we could say less than 0. Okay? Next part, my extremas. I can say that I had a max, and again, it doesn't really matter which one you say first, okay? My max is at x equals 5 pi over 3. I have to take a moment and find f of 5 pi over 3 to find the full location, which means I'm plugging this into the original. Be very careful. Half times 5 pi over 3 minus sine of 5 pi over 3. Now, in order to receive full credit on the AP test, they don't care if you don't finish your arithmetic, meaning your addition, subtraction, multiplication, division, exponents, radicals. As long as you finish your calculus and your trigonometry, your trig functions, you get full credit, which is a nice thing. Okay, so in this case, as long as I find what sine of 5 pi over 3 is, I can leave that as messy as I want, okay? But for now, we are going to finish this off. We end up getting, this ends up being 5 pi over 6 minus, and this ends up being radical 3 over 2. If I want a common denominator, I multiply by 3 over 3. So I end up with my x value was 5 pi over 3, comma, common denominator of 6. I have 5 pi minus 3 radical 3. Again, you won't be expected to clean it that much. I just wanted you to have a nice definite answer there, okay? And because it's my only max, I can call this my absolute max. Another synonym you might see is a global max. Okay? Let's do the justification. This is my max because, okay, it's a max because f prime of x changes from, so I know I went increasing to decreasing, but I found that because f prime, the derivative, changed from positive to negative. Okay? So there's, let me go marking. There's my answer for increasing and decreasing. Here is my answer for my max. And I still have to do my min. I'm running out of room a little bit, but we'll scroll on down a little bit. So I'm going to write my min over here. My min, we found, is at x equals pi over 3, which means I'm going to have to find f of pi over 3. Sorry about that. My pen seems to be running out. All right. So now, remember, I'm plugging to find values of max and mins. I have to plug it into the original, which was right here, okay? So I'm writing half times pi over 3 minus sine of pi over 3. Okay? This will end up giving me pi over 6 minus radical 3 over 2. Same thing, get common denominator. And I have, this will end up, so my full ordered pair, let's write it with an ordered pair already, gives me my x value, which was pi over 3, comma, and then my y value, when I combine this, I'm going to have a common denominator of 6 pi minus radical 3 times 3 is 3 radical 3. And because it was my only min, this is going to be an absolute min. Okay? And we can say because we found this was a min, it did change from decrease to increase, because f prime, the derivative, changes from negative to positive. All right, guys, that is our last question. These are lengthy. Please pace yourself with the homework. It is time consuming. I will tell you this is probably going to be the most rewarding homework that you'll do in terms of preparing for AP. These are a huge portion of the test. Okay? For example, a free response question in AP is worth 9 points. Something like this can earn you a good majority of those 9 points. Just being able to find increase and decreasing, explaining, finding extremas and explaining. This is worth a lot, guys, okay?